Okay, hi everyone. I'm here with your 311 lesson. It's titled Are They the Same? Using the Multiplicative Identity. In this lesson, you will analyze a powerful tool for finding equivalent fractions. This way of thinking about equivalence can be applied to many different situations. You will see how it can be used to solve problems and to investigate new applications. So we're going to start by looking at problem 3.3. Problem 3.3 is titled Wonderful 1. Frankie was thinking about her mother cutting the lasagna when she noticed a very useful connection. She recognized that any fraction in which the numerator and denominator are the same is equivalent to 1. In addition, multiplying a number by 1 leaves the number unchanged. Wow, she said, I can use this idea to find a whole bunch of equivalent fractions. She showed her team the work at right. Look, she said, it's the same thing as using a giant 1. Discuss Frankie's work with your team. Does it make sense? Is 3/5 equivalent to 6/10? How can you be sure? Go ahead and pause the video and answer part A. Okay, if you're back with me, hopefully you've answered then part A. So your explanations are all going to vary, but hopefully you said that yes, it is the same. Or yes, it is equivalent. Okay, and like I said, that your explanations will vary here. So B, find at least 2 other fractions or ratios that are equivalent to 3/5. So you cannot use 6/10 because it's already been done for you, but look at the work she did with the giant 1 and figure out other fractions, 2 others that are equivalent to 3/5. Go ahead and pause the video and do that here. Okay, if you're back with me, you have found at least 2 other fractions or ratios. So I'm going to do the first couple. So 3/5 times 3/3, and 3/3 is your giant 1. Sorry, that was not the best one. Would give you 9/15. Could have 3/5 times 4/4, and that would have given you 12/20. 3/5 times 5/5, another giant 1. That would have given you 15/25. 3/5 times 6/6. Remember that 6/6 would go in your giant 1. 18/30. 3/5 times 7/7. 7/7 is in your giant 1. Would be 21/35. Okay, and I'm just going to write 3/5 times 8/8. That's in your giant 1. You would have 24/40. Put it on 3/5 times 9/9. That's in your giant 1. 27/45. Okay, and you could have continued on. There are many, many options here, but these are just some of them. Part C says, what Frankie calls a giant 1 is more formally called the multiplicative identity. Discuss with your team why you think it is called that. Keep this name in mind as you finish today's lesson and be ready to share your ideas. Go ahead and pause the video and answer. Okay, if you're back with me, that means you have attempted to answer part C. As long as you have something of along the lines of, it's called the giant 1. Because the result after multiplying, so after multiplying by 5/5, or by whatever it was in your giant 1, is equal to the original number. Okay, so what that means is after you multiply by 3/3, 9/15 is equal to 3/5. Here, once you multiply by 4/4, 12/20 is equal to 3/5, so on and so forth. We're going to do some more practice with the giant 1. So if you want to look at 3.4, it says use the idea of the giant 1 to find at least 4 fractions that are equivalent to 9/8. So go ahead and pause the video and answer this question. Okay, if you're back with me, that means you have found 4 fractions that are equivalent to 9/8. So we have 9/8 times, could have started with 2 over 2, 18/16. Okay, 9 over 8 times 3 over 3. And that's a giant 1, 27/24. 9/8 times 4 over 4, at 36/32. 9/8 times 5 over 5, 45/40. 9/8 times 6 over 6. Okay, and you only needed 4 of these, but I'm just showing you 44/48. 9 over 8 times 7 over 7. Giving you many options here that you could have had. 63/56. 9 over 8. 9/8 times 8 over 8. 72/64. 9/8 times 9 over 9. 81/72. And my final one that I'm going to do, 9/8 times 10 over 10, would have been 90/80. There are more possible answers here, but you only needed to find 4 fractions that are equivalent to 9/8, and I found 9 for you. Okay, so notice, I just worked my way up. Okay, 2 over 2, 3 over 3, 4 over 4, so on and so forth. Okay, so we're on question 3.5 now. It is titled So Many Choices. Bertrand was feeling confused. There are so many ways to write the giant 1. How do I know which one to use? He whined. How can Bertrand decide which giant 1 to use? Work with your team to answer the following questions and come up with a strategy. Find the missing numbers in the fractions below. And part B says, what computation could help you find the numbers to use in the giant 1s? So go ahead and answer parts A. Pause the video and answer parts A and B. Okay, if you're back with me, hopefully that means you have tried part A and B. So for part A and B, you need to ask yourself, 4 times what is going to give you 44? Well, 4 times 11 is going to give you 44. So 3 times 11 then gives you 33 for your numerator. Again, 12 times what is going to multiply to give you 60? It's going to be 5. And 7 times 5 is 35. Okay, you could also be asking yourself, 18 divided by 3 gives you what? And that is going to go in your giant 1. So here it would be 6. And 72 times 6. Oh, I'm sorry. This one was flipped around. So 18/72 equals 6, or equals your giant 1 times 3. So I did tell you 18 divided by 3 is going to give you 6. But now 72 divided by 6 is going to give you your value over here, which is 12. Okay, so just hang on one second. So hopefully for part B, you kind of heard me telling you what computation would help you divide, would help you here. So you could have said, you could have figured out what to multiply by. So multiplication could have helped you. But you also could have said division. So problem 3.6. Use what you have discovered about finding the necessary giant 1s to complete the following problem. 35/50 times your giant 1 equals blank over 10. So how is the giant 1 that you use different from the ones that you found in problem 3.5? So go ahead and pause and answer this question. Okay, so hopefully you could ask yourself, okay, 10 divided by 50 gives me what? Well, it's going to give you a fraction. So it should have given you 1/5. So how is this different? Well, it's different because the number in the giant 1 is not a whole number. So you could have had either a fraction here or a decimal. You could have had 2/10 here. So it would have been 0.2 is how you would have written that. So if I wanted to multiply 35 times 1/5, that would give me 7/10. We're actually going to skip part B here, so you do not need to do part B. There is one other problem I want to talk about, 3/7. It says sometimes it is useful to express a fraction in lowest terms. If you write a fraction in lowest terms, you use the smallest whole number possible to express the fraction. For example, 60/70ths, 30/35ths, and 6/7 are all equivalent fractions, but only the fraction 6/7 is expressed in lowest terms. Simplifying a fraction is the process of rewriting it in lowest terms. With your team, consider how the giant 1 could help you simplify fractions as you answer the questions below. So we're actually going to skip down to part D. And part D says, work with your team to simplify each of the following fractions and write them in lowest terms. So we have 24/36. So you need to figure out the biggest number that can go in both 24 and 36. So it's going to be 12. So you're going to divide by your giant 1, 12/12, and you would then get 2/3. And that is 24/36 in simplest form. I would like you to pause the video and try number 2 and number 3. Okay, if you're back with me, that means you've tried number 2 and number 3. You should have hopefully divided by 6/6 as your giant 1 here, which would have given you 5/8. And here, in the third part, you should have divided by 14/14, which would have simplified to 4/7. Okay, if you have any questions, as always, just please email me.